Well, good evening, everyone. What a big crowd. It's great to have you all here for the great Chatbot debate. And thank you so much to everyone watching the live stream across the country and across the world and the recording. It's great to have you all part of the CHM community wherever you stand on the issue tonight. I just want to say, whether you're an AI true believer, you're a skeptic, you have no idea what this whole LLM thing is, tonight promises to be a really interesting and vibrant event. We are so grateful, though, to our sponsor for tonight's evening, and I just want to take a moment to offer our sincere thanks to the Patrick J. McGovern Foundation, and won't you join me in thanking them as well? Their generosity makes possible what we do, as well as all of you who are supporting members. I know we had a great crowd at the member reception tonight. I just want to say a special thank you as well to the House Family Vineyards for sponsoring the wine at the reception tonight. So thank you to them. And indeed, tonight, it is such a pleasure. I know quite a few of you probably are new to the museum. You may have heard about this through our event partner, IEEE Spectrum. We are so grateful to have the chance to work together with IEEE Spectrum. It's a great partnership, and this whole event has been a real collaborative process. So our thanks to Eliza and her team there. So I just want to take a moment to reflect on where we are tonight. Here at CHM, raise your hand if this is your first time at the museum. Wonderful. Well, that's great. Hopefully, some of you will be back if you haven't already. Make plans to come back to check out the Chatbot exhibit that we have downstairs, Chatbots Decoded. If you weren't here for the member reception, are not a member yet, consider joining for next time, but make sure in the meanwhile to come back and check out that exhibit, because it brings to life the topics that we're talking about tonight. It's a really fun interactive exhibit. You can talk with Amica in a language of your choice, a robot, and it's got a lot of great exhibits. So do come back if you haven't seen it already. Now at CHM, we're all about decoding technology, its computing past, digital present, and future impact on humanity. And tonight's program obviously really reflects that theme as we explore and debate just how intelligent AI really is. I just want to take a moment here and introduce the experts that we have guiding us through this debate tonight. We are so lucky indeed to have quite a powerhouse on both sides. Representing one side is the University of Washington's Emily M. Bender. She is the director of the Computational Linguistics Laboratory and is a professor of linguistics and an adjunct professor at the School of Computer Science and Engineering and the Information School there. She is known for her critical perspective on AI language models, co-authoring the paper on the Dangers of Stochastic Parrots, and her new book, The AI Con, How to Fight Big Tech's Hype and Create the Future We Want, comes out May 13th. So be sure to pre-order that now. On the opposing side, we have OpenAI's Dr. Sebastian Bubeck, currently a member of OpenAI's technical staff. He previously served as VP of AI and distinguished scientist at Microsoft, where he spent a decade at Microsoft Research. Earlier, he was an assistant professor at Princeton. His 2023 paper, Sparks of Artificial General Intelligence, Early Experiments with GPT-4, drove widespread discussion and debate about AI in publications like the New York Times and Wired. And the ringmaster in the octagon tonight, or I should say tonight's debate moderator, is Eliza Strickland. Indeed, senior editor at IEEE Spectrum, where she covers AI, biomedical technology, and other advanced technologies. She is often on podcasts and moderating programs from South by Southwest to here at CHM tonight. So without any further ado, I'm going to turn it over to her to set the stage for tonight's debate. Won't you join me in giving her a big CHM welcome? Thank you.
Right. Hello, everybody. Thank you so much for joining us here today. This is going to be a lot of fun.
I'm going to take 1 minute to plug IEEE Spectrum before I get to the real good stuff. Just in case you guys don't know us, we are the flagship publication of the IEEE, which is a professional organization for electrical and computer engineers with 500,000 members around the world. So we have a monthly magazine, but we also have a website that's free and open to all. So it's all sorts of great technology coverage there. Now, when IEEE Spectrum started talking with the museum about doing an event, doing this debate, I knew exactly what I wanted to have on stage. I wanted sparks versus parrots. so for the no position, I thought there'd be no one better than Emily Bender. Her paper on the danger of stochastic parrots was written several years before ChatGPT came out. And it starts a firestorm of debate about the risks of language models that was really prescient. And I talked to her over the years, and one thing she told me in an interview really stuck in my mind when I thought about this question of whether language models can understand. She said, "The way we interpret language is imagining the mind of the person speaking to us. So when we encounter synthetic text, we're imagining a mind that isn't there." I thought that was such an interesting perspective. And for the yes position, I wanted Sebastian Bubeck, who had written this preprint, Sparks of Artificial General Intelligence, which shared these early experiments with the language model GPT-4. And I'd heard him on a podcast around the time of that preprint came out, talking about just the differences he'd found between the prior language models that OpenAI had come out with and this new version, GPT-4. And he said, the big issue, comparing the earlier models to GPT-4, he said, the big issue is that the earlier models didn't really get the concept of a cat or a dog. And then suddenly with GPT-4, it was clear to me that it really understood something. So I thought these would be the perfect debaters, and we're so lucky that they both said yes to joining us on stage. So I'll just give you a quick bit of history, a little bit of how these technologies work, and a little bit of what's going on right now. So you probably heard of the Turing test in the 1950s. Alan Turing, the famous computer scientist, came up with this sort of thought experiment. He said, what if there was a human evaluator who had a computer interface and was chatting with both a human and a computer? If he couldn't tell the difference between the two, that would mean that the machine was imitating humans well enough to at least demonstrate intelligent behavior. He didn't quite out flat say it would be intelligent, but he said it would be demonstrating intelligent behavior. And back then, the idea that a computer could pass the test was considered a total fantasy. But time went on. In 1966, an MIT professor named Joseph Weizenbaum created the first chatbot, which was by coincidence named Eliza. And she mimicked a therapist by reflecting your statements back to you. So if you said something like, I'm really stressed out at work, she'd say, oh, why are you stressed out at work? And we're like, I'm really mad about my mom. She'd tell me more about why you're mad about your mom. And it's just basic scripts. But the interesting thing was that people attributed intelligence and emotion to these basic scripts. So Weizenbaum's secretary started asking him to leave the room when she was talking with Eliza because she wanted to have this privacy for these intimate conversations. So then came decades of slow progress. I won't run you through the whole history of AI. It wasn't until the 2010s that we got sort of halfway decent voice assistants like Siri and Alexa, but they were often more frustrating than useful. And then in the 2010s, we saw the beginning of a revolution in AI when a type of AI called artificial neural networks that had been sort of written off as a dead end for ages suddenly had this resurgence. So basically, neural nets are a type of machine learning model that's loosely inspired by how the brain works. They consist of layers of internet-connected nodes or neurons which process information. And the connection between neurons has a weight that adjusts as the network learns from the data. So in neuroscience, there's a phrase, neurons that fire together, wire together. So the idea is information, the weights, the parts that are most interested and interconnected, those weights get strengthened as a machine learns from the data. And what changed in the 2010s was that suddenly these machines had vast amounts of data to learn from. They could ingest all the pictures on social media. They could ingest all the text on Reddit and social media and books. And so they took a huge leap in capability, first in computer vision and then in text processing, natural language processing. So that brought on the dawn of the large language models, that's what LLM stands for, large language models. And they're built on neural networks, and they can reproduce human-like text because they've read so much of it. they've read basically all of the internet. So during the training process in which they're ingesting all this data, they learn to recognize patterns in the data, such as how words and phrases are commonly used together. And that allows the model to predict what comes next in a sentence, or to generate relevant responses based on the input you give it, the questions you ask or the prompts you give it. So that's what enables an LLM to explain quantum physics 1 minute and write a poem in the style of Dr. Seuss the next minute, and write a recipe for eggplants the next minute. So it's seen all these things, and it can basically do anything it's seen before, and then some. And the then some is the interesting part. But as you may have seen, large language models are often prone to really embarrassing missteps. Like the Google Chatbot a year or so ago that advised people to eat at least 1 small rock per day for good health, and to keep pizza toppings from falling off by adding 1/8 of a cup of glue. So when you see things like that, you say, well, what's really happening here? Now a little bit about what's happening today. Just in the past few months, we've seen the introduction of powerful new models that are called large reasoning models. So this is kind of a step up from the LLMs. And these models use chain of thought reasoning to break down a problem into many steps. So they break it down into steps and they execute them one at a time. And that seems to reduce errors. It makes them less prone to these sort of hallucinations or missteps. And it really is, it's interesting to see what a change it makes. I was just testing this today just for fun. And maybe you've heard before there's this sort of famous riddle where you say, there's a man and a cabbage and a goat and a wolf, and you have to get them all across the river, and you have a boat that takes you plus 1 item. How do you do it? How do you do it one at a time so the cabbage doesn't get eaten by the goat and the goat doesn't get eaten by the wolf? Now what's interesting is that language models have this down cold because they've seen it before. You can ask them that version. You could ask them about a mouse and a cheese and a cat. Like, they get it. They're good. But if you tweak the riddle in very simple ways, you can often trip up the language models. So I asked ChatGPT just today how to get just a man and a goat to the other side of the river. They've got a boat. How do they get across? And it told me, the man takes the goat across the river. He leaves the goat on the other side. The man returns alone to the other side to retrieve the boat. Both the man and the boat are now on the original side, while the goat is safely across the river. I said, well, I've pointed out that now the man and the goat, the man was not on the right side of the river, and it said, oh, I'm sorry. The man and the boat should both get in the boat and cross the river together. The man leaves the goat on the far side and returns alone with the boat to the original side. The man then rows across the river again by himself. So you see, it's like trying to put the pieces together, but it just doesn't quite get it. And then I asked OpenAI's reasoning model the same exact question, and it said just put the man and the goat in the boat and put them across the river and call it a day. So you can see something is changing in the way these models can function. And another thing that's happening today is AI agents, like agentic AI you may have heard of. So these are systems built on top of language models that can then take action on your behalf. So they can make a restaurant reservation for you, or find the best flight that goes to Paris, or research the cheapest shoes to buy on Amazon. So in the context of all that, we have the question before us today, which is, do LLMs really understand? And we should think for just a second about what we mean by really understand, because definitions are important in this. When we talk about understanding in human terms, we generally mean that someone has a deep intuitive grasp of a concept, which involves not just knowing facts or being able to repeat information, but being able to apply knowledge in various contexts, to have a sense of meaning and intent, and connect the ideas to a world model, a model they have of the world. Now, when it comes to large language models, the question is whether these AI systems possess a similar type of understanding. So yeah, do they really understand what they are saying, or are they simply mimicking the patterns they have seen in the training data without any true comprehension? And this is the crux of the debate before us today. If LLMs truly understand, it would change the way we interact with the technology as we make AI a more integral part of our daily lives. On the other hand, if they're merely mimicking patterns, we might want to be more cautious about how we use them, how we integrate them, how we rely on them. So we're going to have this excellent debate in front of us. The format will be opening statements from each of the speakers, each of the debaters, followed by a moderated debate in which I will ask them questions. They will ask questions of each other. And then we'll do Q&A, taking questions from the audience, both in person and online. And then we'll end with closing statements. And at the end of the debate, we ask you to participate in the Slido poll again. If you haven't done so already, it's great to do it now so we can get a feel for where the audience stands at the beginning of this, and then we'll check in again at the end. As you listen to the arguments, just consider both perspectives and keep an open mind and try to think critically about the evidence and the reasoning presented. This really is not a technical debate, but also a really philosophical one that touches on the nature of intelligence and understanding, and what it means to be human, and what it means to be human in this age of machine interaction. So without further ado, I would like to welcome our debaters onto the stage, Emily and Sebastian. Remind me, did you want to go first or second? You want first, right. Great. So back in the green room, we flipped a coin, and Emily won the coin toss and is elected to give the first opening statement.
Great. Thank you so much. Thank you all for being here. Thank you to the Computer History Museum for organizing this, and thank you to the folks who are joining us online, either live or in the future. To answer this question in my starting 10 minutes, I'm going to do 4 things, and I'm going to do them drawing on what I've learned studying, researching, and teaching linguistics and computational linguistics since the 1990s. And linguistics is really important here because linguistics is the field that studies how language works and how we work with language. And both of those things are really crucial to answering this question of, do LLMs really understand? So I said I'm going to do 4 things. The first is I'm going to offer another definition of what understanding means. Then I'm going to tell you a bit about what language models are and how they've developed over the years. And then I'm going to lay out the argument that nothing in the development of language models actually gives them access to the meaning part of the form-meaning equation that is language. And without access to meaning, there's no understanding. And then I'll talk a little bit about how people understand language and why that mechanism leads us to sort of be susceptible to the illusion that LLMs understand. As I'm doing this, I'm going to try to avoid using anthropomorphizing language. I'm not going to say that large language models struggle or try to do anything. I'm not going to say that they ask and answer questions, or I'm going to try my best not to, because I think that muddies the waters. And similarly, I will never use the term artificial intelligence or AI without scare quotes, because it doesn't refer to a well-defined set of technologies. I think in general, it is better to always talk about automation, and then we can talk about what it is that we're automating and why we're automating that. Okay, on to point 1. What is understanding? In a paper that I wrote with Alexander Kohler that came out in 2020, sometimes known as the Octopus paper, we gave a technical definition of understanding as mapping from the form of language, so sounds that you heard, signs that you observed, letters that you read, to something outside of language. And that's very narrow, and by that definition, if you tell your voice assistant to turn on the lights and it does so, it has understood that command. So it is possible to create automated systems that do this mapping. But as humans, when we use language, there's usually a whole lot more beyond that. So for example, if I said, look at that parrot over there, right? From the words and grammar alone, you could tell that I'm trying to direct your attention somewhere and that there's likely a parrot over there. But from everything else that you put into understanding, you also know that I wanted you to go look at the thing that I'm calling a parrot, and that I either believe it to be something that is reasonably described as a parrot, or I am behaving as if I were. So that's an example of the very rich kind of understanding that we do. If instead I had said, "Achi no omu o mite," if you don't speak Japanese, the words probably didn't do very much for you, right? But if it happened face to face, and you could see my gesture and my eye gaze, you might have the idea that I was trying to direct your attention to something. And if you looked over there and there was a parrot and it was the most salient thing, then you might have guessed that one of the words I just used actually was the Japanese word for parrot. It's omu, in case you're wondering. And this could help you to start learning Japanese. But all of that inference, all of that meaning, isn't coming from the words. The words weren't helpful to you unless you speak Japanese. I'm sure someone here does. But in this kind of co-situated setting, because you are a person, because you bring all of that contextual understanding with you, you can use it to actually start learning Japanese, drawing on all of those cues. But the point is, large language models aren't going to have that, and that's key. Okay, so point 2, language models. How am I doing? This is really old technology. And it goes back to the work of Claude Shannon, building on earlier work of Markov. And many people here are probably old enough to remember the T9 interface for texting, text on 9 keys, right, where you would type in the numbers, and each number corresponds to 3 or 4 letters in the English T9 keyboard. But given a sequence of 4 or 5, there's only a certain number of words in the dictionary that could have been what you intended. Right? And the interface gave you those words ranked according to their frequency in some training data. And it was super annoying because home and good were the same sequence of keys, and it didn't matter if you said, I'm coming, right? It was always good because that was the more frequent one in the language model, which was just this count of how many there are. So those are the really basic unigram language models. You can make it more sophisticated by counting words in the context of 1 to n previous words. And this has been an important component of automatic transcription technologies, of machine translation technologies, where you basically have one component that says, given that sound sequence, or given this string of, say, French words, what are the possible English words it might have been? Get a range of possibilities, and then you can consult the language model to re-rank them according to what looks the most like the training data. So that was language modeling in the 1990s and into the 2000s. Also, by the way, useful for spell check, right? What are the possible words you can get to by 1 or 2 substitutions or deletions or insertions from what was typed? Rank those by just plain old frequency, or rank them by likelihood and context. And then once you have a language model that is modeling more of the patterns, you can say, that's the wrong there, and pick up things like that.
5 minutes.
5 minutes, okay. In all of these cases, we're using language models to answer the question, which string of letters among the candidate strings of letters that come up in this application is the most probable given the training data? We are always and only dealing with the form of words and not what they can be used to refer to or what they're being used to refer to in that context. There's 2 major differences with what we call LLMs today. The first is there have been advances in machine learning architecture that allow us to take advantage of the enormous data sets that can now be constructed questionably in terms of how it was collected, not consentfully, but can be constructed, have been constructed. And so these machine learning architectures allow us to take advantage of these much larger training sets while modeling the relationships between words that go beyond just, okay, I've got 4 preceding words, can I rank the vocabulary by likelihood? So much more fine-grained modeling of which words are likely to co-occur in which relationships to each other over longer sequences of text. Also important, that training data is undisclosed, with a few exceptions. The folks at AI2, for example, I think are pretty open about their training data. The second big change with large language models is that the system has been turned inside out. So instead of using them to answer the question, which of these candidate sequences of word spellings is the most likely, we're instead using them to repeatedly answer the question, what is a likely word to come next, over and over and over again, right? So those are the 2 major differences. There's also 2 minor differences. One is some additional training, for example, something called reinforcement learning from human feedback, where you have many, many data workers who are shown outputs from systems and either compare to this one's better, that one's better, or just good, bad. And that allows the system designers to basically shape the probabilities towards the words that get the thumbs up from the data workers. And then there's some additional processing steps between input and output. So for example, you might be scanning user input for arithmetic questions, and in that case, sending that off to a calculator to avoid the embarrassing LLM output that can't do math, even though it's a computer. Also, sometimes user input is turned into a web query. You retrieve those documents, and then input those documents plus a system prompt that says produce a summary to do what's called retrieval augmented generation, which is effectively papier-mâché of the documents that came back while discouraging the user from going and experiencing that information in its own original context. And then there's system prompts in general. When you type something into the input box for ChatGPT, that is actually not the only input that goes into the system. There's a whole prompt wrapped around that, and also the conversation history being put in each time that you only then see a little bit of output afterwards. There's a bunch of stuff that's hidden in the interface. All right, 2 minutes, okay. So the result of all of this is coherent seeming text that's shaped to be pleasant according to the preferences of the data workers who did that reinforcement learning from human feedback, but it is still fundamentally the result of repeatedly answering the question, what's a likely next word. So why does it seem to understand? The answer is, it only makes sense because we're making sense of it. You might think when you're understanding something you're listening to, something you're reading, that the meaning is just there in the words, and you are unpacking the words and getting the meaning. But research in pragmatics and psycholinguistics shows us that's actually not how it happens, that we are continually just doing our best to figure out what that person must be trying to convey, and using the words as a particularly rich clue to doing so. And in order to do that, we have to imagine a mind behind the text. So when we encounter the synthetic text that comes out of a chatbot, we do the same thing. We do it reflexively and instinctively, and it is very hard to then remind ourselves, actually, that's all on our side. We made up that entire mind to make sense of that text. So, to conclude, extraordinary claims, such as large language models understanding, require extraordinary evidence. Also, you have to define understand if you're going to make that claim, and it has to be defined in a way that it's informed by what we know about how people understand language, and it has to be falsifiable. Hiding the training data or even information about what's in the training data in general is anti-scientific because it doesn't allow people to reason about how the training data plus the input leads to the output, and also anti-social because it doesn't allow us to reason about when it would be a good idea to use these things. And then any texts that take the form of text in, text out might look to us like the system is answering questions and reasoning and being smart, but in fact, we should be careful that those are actually only testing how closely the system is modeling the distribution of the words in its training data and how closely that training data approximates the testing situation. So in short, do LLMs understand? Emphatically not.
Sebastian?
Yes. Hi, everyone. So I will have a quite different take from what Emily has been presenting. And maybe I want to start by acknowledging that the question that we're debating tonight is sort of a weird question. And what I mean by that is the following. So just the other day, I was listening to a talk like this one. It was in physics. And the professor, a Harvard professor, was talking about Einstein's theory of general relativity. And in his presentation, he said, Einstein obviously did not understand anything about general relativity. So this is something really, really important to me, that understanding is kind of in the eye of the beholder. Like, I have had this experience myself many, many times in my research field, where I feel like, you know, some other researchers, maybe they don't really understand what's going on. But of course they understand. Come on, I mean, they are researchers in this field. Of course they understand. But what I'm trying to say is that there are different bars, different levels at which we might decide that somebody or something understands. So that's point number one. Point number two is that, as you know, both Eliza and Emily said, we need to have some definition of what understanding means. I totally agree with that. The problem is humanity has debated the meaning of understanding for millennia. And kind of spoiler alert, we're not going to figure this out tonight. Okay? None of us has a killer definition of what understanding means that subsumes these millennia of work. So that's, I think, something really important. Now, if I'm not going to present to you a definition of understanding, what I want to do is to go back to maybe things where we have numbers, solid numbers, we understand things very precisely, and what I'm talking about are benchmarks. And benchmarks are a good way for us to assess the rate of progress that we have seen in the last couple of years. So I want to take a few minutes for all of us in the room to take stock of how far we have gone in the last few years. And then I will move back to the understanding question. So 2.5 years ago, just before GPT-4 came out and just before ChatGPT, I was at a workshop on mathematical understanding of neural networks. And somebody from Google showed me the latest model that they had trained, Minerva at the time, a math model. And this model, I was just absolutely shocked that it was able to solve one high school level question. It was just a very simple question about lines intersecting itself, you know, like really nothing difficult. But I was shocked by that 2.5 years ago. Today, we have systems that are in the running to get a gold medal at Mathematics Olympiad. This is I think it's important to recognize this, and this is irrespective of whatever definition we want to put on this. This is the rate of progress that we're seeing. So the mass benchmark, this was high school level competition. 2.5 years ago, chatbots would get like 20%. As of early last year, it was completely saturated. We could not use this benchmark anymore because the models were just becoming too good on it. Okay, so that one we discarded. Now, there was another benchmark which was very popular called MMLU. This is a benchmark that was supposed to test essentially high school level understanding of scientific questions. And that was a really important benchmark. Like all the CEOs of big tech were, talking about it, and it was kind of moving markets worldwide, whether somebody would get plus 2%, plus 5%. Mark Zuckerberg would talk about it all the time. You don't hear about it anymore at all. Why? Because it's completely saturated. Like our models are just too good on this. So we keep coming up with newer and better benchmark. We are now at the stage where the latest and greatest benchmark that people are fighting to get higher on is called frontier mass. And frontier mass, as the name suggests, these are really very advanced research questions in mathematics. Not open question, but still questions that you would ask, an early graduate student in mathematics. And when they came out with the benchmark, I think it was maybe 4 months ago, OpenAI's latest reasoning model, O1, would get 4% of them correct. So again, everybody was very happy. Okay, here is an example of a benchmark that is really beyond the capabilities. 1 month later, we came out with O3, in fact, O3 Mini, which is even a smaller model. It ranks at 30%. And I don't even know if there is a single human being on the planet that can get 30% of those problems by himself or herself. So this is really, the kind of rate of progress that we're talking about. Okay, but benchmark, I'm personally not a fan of benchmark. In the Sparks of AGI paper that I wrote 2 years ago, the whole point was to say we need to move away from benchmark because, and this is where I think we will agree, they do not show understanding. No matter how good you craft your benchmark, it's going to be very hard to extract understanding from it. To me, understanding, you can judge it by interacting with the system and being very careful about not anthropomorphizing the output that you see, but really trying to probe and ask probing questions to further see how far the understanding goes. Because again, understanding is not a binary notion. It's not a 0 or 1. It's really a continuous metric. How far do you understand things? So I want to go back to this kind of more pragmatic view of understanding, which is more what do those systems can do for you? Can they help you understand new things in some way? And this is where I would challenge everybody to think about their own experience with those models. Because this is a great thing, as opposed to 2 years ago, is that probably everyone in the room has had their own experience with the chatbot. So you know for yourself whether you think that they understand or not, whether they were helpful to you in one way or another. And I will give you just my personal experience. So recently with the O3 Mini, so there is a research question in mathematics that I know there is no answer anywhere on the web. How do I know? Well, it's a problem that I personally thought about. In fact, I wrote a paper on it, but I never had time to publish it. So it's just in my Dropbox, there is like 2 other human beings that have seen it. I think nobody knows the answer. And I asked O3 Mini this question. If you are interested, the question is just some optimization question about the length of the trajectory. It doesn't matter the details. The point is, of course, O3 did not solve the question. That is way too much to ask. I did not have any hope of this. But it gave me a suggestion of a connection with another field that took me personally 3 days to discover. And this model, by reasoning and thinking about the problem for 2 minutes, was able to make that connection. Does it mean that it understands? It's really hard to say. Was it extremely helpful and did it accelerate me and I could have spent those 3 days on something else? Yes, absolutely. So this is where I want to take the discussion. Now, I want to give one more point in the favor of the kind of lack of understanding or what is exactly understanding. And to do this, I want to harken back to the philosopher's debate of what does understanding mean. And I think there is a possibility that at the end of the day, understanding is a human journey. It's all about our own understanding. And this is why I say that rather than asking whether the chatbot understands, you should ask yourself whether the chatbot helps you understand more things. And for example, in mathematics, it's entirely plausible that within the next few years, we would see breakthrough from those models that discover new things, that prove new theorems that no other human beings has been able to prove. Yet the mathematics community might not accept it. It will accept that the theorem has been proven, but they will say, and in my opinion, rightly so, that we still do not understand. We will only accept that we understand it once a human is able to fully grasp the entirety of the proof. So this is where I want to end this introductory statement.
All right, thank you very much. Okay, let's start. I want to start by asking you both about a report that just came out from the Association for the Advancement of AI earlier this month. Included a survey of 475 AI researchers. About 76% of the respondents said it was unlikely or very unlikely that scaling up current approaches would succeed in achieving AGI, and 80% of the survey respondents said current perceptions of AI capabilities don't match reality. And it's a little bit adjacent to what we're talking about with understanding, but I was curious to see what you make of those results, since they show a fair amount of skepticism within the research field that what the track that the technology is currently on is going to lead to great things. Sebastian, I'll start with you.
Yeah, this is actually a really interesting question, because this is one thing that has shocked me in the last few years, is that actually the academic community and researchers in general have been the ones who were almost the slowest to understand what's happening. And maybe for good reason. I mean, you know, it's the problem with LLMs is that they go, certainly from the perspective of our mathematical understanding of those objects, it goes so much against everything that we thought that we understood about neural networks and artificial intelligence. We never thought as a research community that something like ChatGPT would be possible at all. So I think there is a lot of that skepticism that remains. So that's point number one. Point number two is also, what do we mean exactly by scaling up? Because as you said in your introductory statement, right now we have these new reasoning models which are scaling up along a different axis. Mm-hmm. To me, this is all the same thing. I don't distinguish between all these different methods. It's all the same from a certain level of abstraction. It's all the same. But it is not the kind of pure pre-training paradigm that people have pushed for from GPT-1, GPT-2, GPT-3 to GPT-4. So it's a slightly different scaling paradigm. So maybe, you know, they are also replying in the sense that the classical pre-training will not get you to AGI. Mm-hmm. And this I completely agree with, I mean, absolutely. Mm-hmm. But whether as humanity, as a group, we're on track towards AGI, mm-hmm. It's plausible.
Mm-hmm. Emily, your thoughts?
Yeah, so starting with the second one of those questions, I think that one's a well-grounded question. So to say, does the hype match what functionality we actually currently have? I think that's a reasonable question to ask people, and the people who build the systems might be in a good position to answer it. And so that one doesn't surprise me. It matches my view of reality. The first question, I think, is really broken as a survey question because AGI is not defined. Mm-hmm. So unless that survey had a specific definition that people were answering with respect to, it's a failed survey question. And I also have to say that I really object to the trope that we often see in discourse from researchers, but also from journalists sometimes and CEOs, that there is a future point where AGI will exist, and it's just a question of, are we on the right path to it, and how fast are we going down that path? And I object to that in a couple of ways. First of all, there's no reason to believe that this thing that's not defined necessarily exists in the future. And secondly, that's not how science works. It's not about picking a path and running down it. It's a community effort where people branch out and explore and tell each other what we've found. And to your point earlier, Sebastian, about would a theorem proof that came out of an automatic system count as having proved the theorem if the mathematical community couldn't make sense of it? I think that goes directly to the fact that all scholarship is conversation. And if you do something on your own to your own satisfaction, that's not yet science or scholarship.
I mean, there is also this thing of doing something in the real world. Like, if you have discovered, I don't know, a new formula in chemistry and you can create new compounds, like this is something, it's hard, concrete evidence that you have done something. You don't need to talk about it. You have it and you can build new things with it. So this aspect, this kind of pragmatism of looking at what they can do for you. If I want to, like, let's take a very extremely concrete example. Let's say I want to build an app. And I ask one of those models to build the app for me. And let's say, right now, I'm not saying it can do it, but let's say in the future, I just specify in natural language what I want. I come back the next day and boom, the app is there. Maybe it's even already installed on my phone. Everything is there. Did the model understand on the way of creating this? In a way, I don't really care. It did something for me.
So do you care if it understands? Like, what are the problems
Right.
with not?
So the reason I care about this question of whether or not they understand is that a lot of the discourse around this is going to be useful as a robotherapist, a robo-lawyer, a robo-tutor is premised on the idea or the vibes that it seems to be understanding. And that is really problematic. Like, I really resist ever being called an AI researcher. I am not interested. I'm a computational linguist. I was minding my own business doing grammar engineering. Right? And then all this stuff happened, and I realized that linguistics really has a lot to say. We are the ones who do have a definition of understanding, even if other people have struggled with it for millennia, right? And therefore, I can see, so another really important thing from linguistics is that the language part is not the same thing as the world or the imagined world being talked about. And I like to use the metaphor of, because I'm from Seattle, all right, a raindrop splattered window, where you can focus on the raindrops and the pattern that they're making, or you can change your focus and look through at the world outside. But when you're doing that, the raindrops are actually influencing how you can see what's outside. Information encoded in language is like that. And linguists focus on the structure of the language and how it allows us to see the information in it. Where I notice a lot of people who are interested in doing language processing from a more computer science point of view just imagine that they're going straight for the information and don't see the raindrops on the window. And so I think the question of does something understand is really important because it allows us to stop and take stock of whether any given application is a good idea.
Yeah, so I want to respond to that. So I would strongly advise anybody in position of power to make decisions based on vibes. That's not a good idea. They shouldn't do that. Nobody should do that. I also would advise them against making decisions based on whether they think this object, this system is understanding, even if there is a perfect definition of understanding. That's also not a good viable path. What I think we have to do in those situations, if we're talking about, to use your word, a robot doctor or a robot lawyer, we have to create benchmark. We have to create tests that, just like we test, we have tests to test human beings, whether they are capable of becoming a doctor or of becoming a lawyer, whether they are ready for it. We should start to create those tests for the AI systems too. And those tests will be very different in nature from the tests that we're using from humans. I hate when people are running, let's say the USMLE exam, for example, on Chatbot. This is nonsense. It doesn't make any sense. You're not testing whether the system can become a doctor just because it can pass the USMLE. That's not a reasonable thing to do because there are so many things about human beings that you assume. They remember what they did yesterday, for example. Chatbot won't remember. So you need to come up with new tests. And this is where I think there is something a little, in my own view, dangerous about pushing people away from the field is that we need actually more people to start thinking about this question. We need to create those tests so that exactly we can start to have a solid route towards large-scale deployment.
On the question of new tests and benchmarks too, I'm curious about both of your thoughts on something called the ARC contest or ARC prize, which stands for Abstraction and Reasoning Corpus, and which is meant to measure progress towards artificial general intelligence. But it's an interesting one because it has tasks that aren't too hard for a human. Like often they're patterns of colors, and there's some underlying logic to how the patterns are presented and how the colors are arranged, and you have to figure out that pattern and then apply it to on another grid or something. So it's meant to thwart systems that memorize and really test the ability to have abstract reasoning and generalization And the first version of ARC, I think the OpenAI's 03 got an 87%, and they kind of said, okay, well, that one's done. But they just launched a new one today, and I believe they said that 03 gets about 4% on it. So that seems like, at least it's a new frontier. Do you think that kind of test could evaluate understanding? I'll start with you.
Yeah, no, it's really interesting. So maybe let me recount the story.
Sure, sure.
So there was this benchmark called ArcAGI, and the creator of the benchmark kind of claims that, you know, once a model, a system can solve this, this is going to be a real, you know, milestone on our journey to AGI. Maybe it's not quite AGI, but it's really going to be a major milestone. All previous models were stuck at 30% or something like that. I think human beings are around 80%. And then 03 end of last year, which reaches 85% of it. So just crushes the benchmark, and you know, without revealing anything about what's going on inside 03, it's really like true generalization to this benchmark. Now, as soon as that happened, this is where, again, the goalpost moving of, okay, but it's not really that's not really what we meant. It's not really understanding. And then, you know, now they come up with this new ArcAGI 2, and indeed, 03 gets a meager 4% on it. I have to say, I looked at it today. I wasn't able to solve many of those questions myself. It's a little bit ill-defined, so maybe they will refine it, and you know, we will find that not everything is perfect. And I think this goes into the bigger question, which goes back to my previous point, namely that creating benchmark is a difficult task. It's real hard work. You understand that as a society, it's a full-time job to create benchmark for humans. Like to create those tests, you know, I mean, we have the educational system which is entirely built around that. So we have to reinvent the entire system for AIs. So I think it's hard to pin too much on that particular example, both one way or another, positive or negative.
Emily, I'd love to get your thoughts.
Yeah, so I have a lot to say about benchmarks. I have a paper that came out in 2021 with Deb Raji and some other colleagues called AI and the Everything in the Whole Wide World benchmark, which we found a really nice parallel between the way that some of the natural language processing and image processing benchmarks were being used to this wonderful children's story called Grover and the Everything in the Whole Wide World Museum. And in that story, Grover goes into this museum, and there's a room of things that are long and skinny, and a room of things that are very heavy, and a room of things that are ticklish, and he goes through all these rooms, and then towards the end, he says, I've seen a lot of things in this museum, but I haven't seen everything in the whole wide world yet. And then there's this door with a sign on the top that says, everything else. And Grover opens the door, and of course, he's in the outside world. And the point is that any given selection of things is only a selection. It's only a sample. And one of the real traps with natural language processing is we use language to talk about everything. And so when we design synthetic text extruding machines that can output plausible sounding text on any topic, it's really tempting to think, oh, this might actually be good at helping me solve math problems, and this might be good at helping me diagnose based on my symptoms, because it can send back text that looks like what you're looking for. But there is no way to actually test for full generality. And furthermore, I would say, what's the point? Right? When we're building technology, we want to test for functionality. We want to know that the system that we're building works well within certain tolerances. And here I'm thinking of Dr. Tamit Gebru's work on data sheets for data sets, where she took inspiration from like electronic components that say, okay, this thing is going to oscillate at 32,000 hertz, give or take 1. Right? And that is the data sheet for this thing, and we can pin it down, and so we can know in which circumstances we're going to use it. The idea behind data sheets for data sets is that we should have similar ideas about what's in a data set so that a machine learning model trained on that data set, we could know when to use it. And as soon as we're talking about AGI, something that is general purpose or whatever, it becomes ill-defined to test for that. And I think ill-defined as a goal. Right? So my take on the ARC prize is it's not a test of progress towards artificial general intelligence, and what I understand about the test that was run with, I think it was 03, was it wasn't just cold, okay, here, do this thing. It was, here, you know, try this. You know, here's a few examples. It was few shot rather than zero shot. And you know, I don't think there's any way that you can interestingly generalize from how well it does on that set of puzzles to really anything. And one last thing I want to say about benchmarks is we don't create benchmarks for people. We create licensing exams. We create academic exams to see how well someone has learned the material in a class, how well they are prepared for medical school and things like that. But that's not benchmarking people. That's not saying how well has this person been developed towards some task.
I agree with everything you just said, just for the record. Absolutely. Maybe one slight addition that I would give to what you said is definitely I think ArcAGI doesn't make any sense as a general purpose test, and such a test does not exist. But that's exactly the point. I'm a big fan when you say that we have to have a functional form in mind for where we want to deploy. We don't want AGI just to come and try to solve everything. We want to try to deploy AGI maybe to help with diagnostic in a very limited setting. And then what I want to say is we want to develop a benchmark for that limited setting to see how well it performs, can it help the doctor, things like that.
So why not have, sure, a benchmark for diagnostics based on symptoms, and then purpose-built systems for doing that with disclosed training data?
I mean, why not? Just because the other thing works better. That's why not.
The other thing is environmentally ruinous. It's built on stolen data, and it's built on undisclosed data, so we can't decide when to use it.
That's hard to respond to.
Let me take a slightly different
obviously
tack.
I disagree with everything, just for the record. But.
Let me take a slightly different tact. So these are the debates that computer scientists have and computational linguists have. But think about this perspective, think about it from the perspective of, the average person who's just trying to keep up with what's going on in technology. They see headlines like, last week the New York Times had a headline, "Digital therapists get stressed too," and it would describe the study that found that ChatGPT showed signs of anxiety when users shared traumatic narratives with it, and that its anxiety levels then dropped after it did a mindfulness exercise. So you could see how people would kind of get the impression that there's like a real mind there, something that's suffering, in fact, in that case, very tragically. What do you? Is there a danger in letting people believe that there is a mind on the other side of this technology? Emily, I'll start with you.
Yes, right? Because if you tell people, hey, this thing has the answers, or this can be your therapist, this can help you feel better, or this can help you diagnose, or this can help you deal with your legal troubles, and by the way, it's super smart, and it's been trained on everything we could scrape off the internet, and it knows everything, and it's objective, then yeah, we are not setting people up to make good decisions. As for what to do about that journalism, my advice to the general public is if a journalist is anthropomorphizing things, especially that hard, skip. You don't need to read that.
Thoughts?
Yeah, no, this is not a great paper. These buts are important, because this is a very delicate and subtle topic. Like any take which is kind of categorical, yeah, we should completely ignore that, it should absolutely not be used for X, Y, Z, I would be wary of such claims. So in the example of this paper, yes, not great, but there is something maybe useful for the AI researchers, not for the general public, but for the AI researchers. There is something about the prompting of the model and understanding exactly whether you can surface some good behavior by putting it, quote unquote, in the right mindset, even though there's no mind there. To be clear, but it's just, I don't know what other language to use. This is also the thing, is we need more work in this direction to develop the right vocabulary to talk about these things. I also don't like the term artificial intelligence. It's something else. It is intelligence, it is understanding, but in a different way from human beings. And it needs to have its own vocabulary around it. And maybe it's going to take decades to develop this new field of study. And the whole difficulty is that we don't have decades. A century ago, when we developed quantum mechanics, physicists were making all of these wonderful discoveries, and they could take 10, 20 years. In fact, it took more than 50 years to have the quantum field theory. But the point is, they had time to do that. Today, we don't really have the time to do that because the progress is so fast. And so this entire conversation also has to be rooted in the reality that I talked about before, that 2 years ago, I was amazed that the machine was solving a single high school problem, whereas today, they are in the running for a gold medal in mathematical Olympiad. So this has to be in the background of everything we say.
Wasn't that one where it got to submit like 10,000 answers, and then they
Yeah, so this is Google. Google, they are not doing it right, but but OpenAI is not doing it like that.
All right, but OpenAI is not at all open about what you're doing. we don't know if those problems are in the training data or very similar ones are in the training data.
There are 400 million people using it weekly, you know, so it's pretty open, actually.
Open means we know what the training data is. Open means we know what the steps are. Open means we know what the system prompt is. Open means we know what your carbon footprint is. All of that would be open.
Yeah, I think Sam alluded to the fact that maybe we're not on the right side of history with respect to open source and open access, so maybe there will be more news in that direction soon.
We're going to turn to audience questions in just a minute, but I wanted to ask one question of you both before we do that. What would you have to see to convince you that you're on the wrong side of this debate? What kind of behavior or evidence?
So I would need a very clear definition of understanding. I would need something experimental where all of the experimental parameters are known and open, every last thing about the training data, so that we can then reason about, okay, getting to this output, given that training data, given the input, given the training architecture, given the system prompt, there is no way to do that without XYZ thing that connects to the definition of understanding.
Sebastian?
Yeah, I mean, for me, it's very, very concrete, actually. So, you know, I spent, I don't know, the last 15 to 20 years doing research in mathematics, and I had many extremely joyful moments reading papers and getting a new, deep understanding from one of those papers. And I would feel that I'm on the wrong side of the debate is if, let's say, 10 years from now, or for that matter, at the end of my life, I don't care about 10 years, but if in my lifetime, I never have such a moment where I realize something as deep as I realize when I read a paper written by another human being who spent, you know, maybe years working on it from an AI system. If I don't get that, then yeah, I was wrong.
All right, I'll do a few of these audience questions. There's a lot of really interesting, provocative ones. A lot of people are kind of curious about how we draw the distinction between human understanding. Well, so for example, one person says, is a statistical representation of the world different from how humans understand the world? Other people say, like, are we just doing the same thing? Are we just predicting the next token when we think?
So I want to take on that, are we just predicting the next token thing? That is an inherently dehumanizing argument. That says, you don't think that I actually have an internal life. And I don't want to have that conversation if you don't think I have an internal life.
Yeah, I guess my perspective is kind of similar, but I turn it the other way around, which is I don't understand how you work, and I don't want to make any assumption about your inner working when you're speaking and when you're, you know, giving me understanding and meaning. And the same way for the AI system. I don't care about how it works inside. This is not my business. I mean, it is, but okay. Not for the perspective of, you know, whether it understands or not. It's doing something, and it's giving me content, and then I judge for myself whether, you know, it's useful or not.
Another question is, to what degree does understanding and knowledge need to have a degree of physicality? Like, for example, I guess if my friend tells me how to play pickleball, gives me all the rules and the instructions, tells me how it feels to play pickleball, I watch videos of playing pickleball, do I really know how to play pickleball? Do I understand it? Or do I have to go out and do it myself to get the hang of it?
Sometimes in linguistics and philosophy, you hear this question as, does understanding have to be embodied? And in order to actually really learn about the world and really learn a language, you have to have embodied experience. And I think that embodiment is important, but I think even more important is socially situated relational experience. That meaning really is in the relationships that we have with other people. And if you look into it, if you get into the details of sociolinguistics and language change, we find that words are constantly changing in what they mean based on how we use them. And that happens because we are successfully using them as these little tokens as to like clues to what we're trying to convey. And then that colors the word for the next time we're going to use the clue. And so it's really all fundamentally in the relationships with other people. And a large language model fundamentally can't do that. We might, in talking to it, do our half of it. And people certainly form attachments. But again, that's all on the person doing it. And how lonely is that? to form a strong, strong attachment to something that's not there?
Yeah, so I mean, the way I interpret this question is about whether multimodality is necessary for general intelligence. And I think this is a frontier research question. Nobody really knows the answer to it. Again, none of the terms are really well defined, granted. But even with this ill-definedness, we don't really know. I have a belief, personally, that it's not needed at all, that you can get to a general intelligence in the sense of everything that I have discussed so far, purely through text, purely through digital access to the internet. You don't need any physicality. You don't need to see anything. You don't need to hear anything. You can get intelligence purely from thoughts and reasoning. That's my belief, but it has to be. It's not confirmed yet. Now, maybe one more point is LLMs. You know, there's nothing special about text. I mean, text is just useful because there is a ton of it, and it's easy to process. There is a ton of videos, there is a ton of images, but it's a little bit more cumbersome to process. Text, there is a lot of it, and it's easy to process. But the technology itself is completely agnostic to the modality. It can be applied to vision, it can be applied to audio, and indeed, ChatGPT now can see, can hear, you can interact with it, you can turn on your camera, and you will have fun interaction. I mean, my kids have fun interactions with it that way.
Yeah, that's a related question. Someone says, do you think AGI, I'm not sure if they meant AGI or AI, do you think AGI will understand the world better without human language? Another different basis of understanding, I guess.
Without human language?
Yeah, without human language.
No, so I think human language is wonderful. It is very information dense. Like in an image, in the access to the other modalities, there are so many repetition. Like even audio is extremely repetitive. Maybe what I say is very repetitive. But these repetition, you have really way less of them in text. So I think actually text is kind of necessary. Like maybe to put it differently, if you wanted to get to a general intelligence only through interacting in the world, then I don't really see another way to do it than evolution for billions of years on planet Earth, and then we're here.
So that question suffers again from the problem of AGI being undefined. I want to take issue with the idea that text isn't special. Text is really special. There's a lot going on in there.
I love text. I mean, it's not special from the perspective of the technology, but...
So it's not special if your perspective is, it's just data, and I'm going to crunch the data with my neural net one way or another.
Yeah,
right?
no, I love text.
But I think it is special in that text is a reflection of language, and language is how we build our social world and how we interact with each other and how we do what's effectively telepathy, right? How we get inside somebody else's mind. And if we have systems now putting synthetic text in front of us and sort of spilling it into our information ecosystem, that's a huge problem because text is special.
Now, this is the top question, been upvoted the most, so I have to ask it. What role do wealth and power play in who decides whether LLMs understand? Tough one.
So who decides? You all get to make your own decision. That's the point of events like this. But who decides in terms of how the political discourse goes? Are we making policy decisions based on the idea that LLMs understand? Then their wealth and power very much come into it. And furthermore, the political economy around developing these things is further centralizing wealth and power. Data became power. I want to point out that before, you said that question you're asking was just in your own Dropbox. Is Dropbox one of the companies that made a deal with OpenAI?
I don't think my Dropbox is being sent to OpenAI.
I don't know, because you don't tell us what's in your data.
Yeah, sure. Yeah, so who decides? Yeah, you all decide. That's definitely the right answer. I think also we have to acknowledge that we live in a world which is run by capitalist societies and that are trying to get ahead, build things faster, better, etc. If those tools, because at the end of the day they are tools, like this is what they are, if they make you more productive, if they make you that you can realize your ideas quicker, if you can do your work in a shorter amount of time, then they will just diffuse that way. So it's the decision is distributed. There is no single entity that's going to decide.
We have a question, maybe I'll make this the last question, then we can do our closing statements. A question about emergent behavior, which is when something complex, it's it says, emergence occurs when a complex entity has properties or behaviors that its parts do not possess individually. So what are your thoughts on this concept? And I suppose, is some understanding, like in the human sense, something that could emerge? Want to start?
Yep, so did understanding, and when I talk about understanding, I'm talking about understanding of language, emerge at some point in the evolution of humans? Well, clearly, right? Because at some point we went from entities that didn't have language to entities that do, and the ability to understand language emerged. When we're talking about emergent behavior with machine learning systems, again, these claims are unscientific unless you have full open access to the training data. And furthermore, we have to be careful about looking at how we're interpreting input-output pairs as question-answer pairs, and compare that to what other kinds of computation might have gone from that input to that output before we actually make the extraordinary claim of emergent behavior.
No, I think emergence is definitely real. I have a hard time, to be honest, understanding how this is debated, frankly. And I would push back on the fact that you need to know every detail of the system to tell whether you can understand whether there is emergence or not. And the reason is you can run your own experiments. I mean, before embarking on this journey of building LLMs myself, I was running experiments on neural networks, building toy settings by myself, just alone with a very simple access to just with my own computer. And I could create settings where I would see this emergence phenomenon. So just to ground it, to make sure we're all on the same page, one example that I looked at was just to train a model to solve systems of linear equation. You remember like in middle school or wherever, where you do x plus y equals 2, x minus y equals 0, what are x and y? Right, this type of question. And you can see a setting where suddenly there is emergence where the system is able, from learning only with systems of linear equation with a few equations, to solve them with many equations. This is just an emergence that you can see literally in the lab by yourself. You don't need to have access to, like the best possible models.
Mm-hmm. All right, with that, I will ask you both for closing statements, about 3 minutes. Emily, would you like to begin, since you began before?
Sure. What would I like to leave you with tonight? I would like to leave you with the idea that nothing is inevitable. If people say this is here to stay, we have to learn to live with it, you can say no. Refusal is really important, right? And that is especially important in our systems that are already creaking and about to get much, much creakier. I'm talking about education, I'm talking about healthcare, I'm talking about our legal system, I'm talking about immigration proceedings. All of these places where synthetic text looks like a nice, handy Band-Aid, quick solution because there's not enough teachers, there's not enough therapists or whatever. We need to say no to that because it's actually worse than nothing. And saying no, I think, starts with refusing it's not just a fun toy to play with, all right? It's not a good tool for search. Anytime somebody is saying, oh, here, use this, it's artificial intelligence. There's my scare quotes, right? Remember, in your back pocket, you've got no. And I'll stop there.
Yeah, my take is quite different. And I would say in general, like I think you all decide, and I'm kind of against the scare tactics and trying to say that this is scary and this is just going to be bad. Like we're smart enough to judge by ourselves when we interact with these tools, when we use them, whether they bring value to us. So that's point number one. Point number two, I want to come back actually to something that I thought would come back more in this discussion that you brought up, Eliza, at the beginning, which is these riddles where you change just a little bit and then it's completely wrong. This goes back to the point that I was trying to make when I said that these topics are complicated and actually quite subtle. And I think there is truth both in the parrot and in the sparks. It's a mix of both. On certain topics, they act more as parrot. On certain topics, there is a little bit more of the sparks. And what I see is that, maybe at the time of GPT-3, it was more like this. GPT-4, it was maybe more like this. And, we're starting, I see the balance shifting. But definitely, both modes are still in there. So it's a complicated, really, really complex topic. With all of that being said, there is definitely a wave right now of more and more people interacting with those models and realizing how powerful they are. One thing that was really, I don't know, enlightening to see was when Sam tweeted one of the stories, fiction stories that our newest model was writing. He just tweeted that. And then it was noted by noted authors, like creative writers, that they were moved by that story. And of course, it's very, I know what you're going to say is that, you know, you can only be moved by something that another human being wrote, etc. Sure, but this person said, you know, who is a noted author, that they were moved by it. So I think this is just, you know, a wave that it keeps increasing. How far it's going to go, how high is it going to go, nobody knows. And if somebody tells you that they know, actually, maybe you shouldn't listen too much. But we can see the rate. The rate is astonishing. And I'm certainly in the camp that I'm very excited to see what the next few years are going to bring.
All right. So with that, let's thank our debaters first. Yeah, I really can't imagine two better people to present these points of view. So as you may remember, Slido, we have the poll going. We asked for you to vote at the beginning. Oh, this is post-debate. So yes, please, you know, pull out your phones if you can. Give us your read on how what you think now, and if the needle has moved at all.
Wait, we see it live.
Yeah.
That's,
I don't know when we'll call it done. But yeah, let's ask David to come back on the stage to give us our wrap-up.
Well, thank you very much, everyone. Just to go back at the start, we started at 64% no, and now we were up again on that no. Just to bring it back, the latest is, well, look at that. Wow.
We changed
The yeses
our minds.
have been voting while I've been coming up on stage, and look at that. I have to say, it is pretty impressive. We did see 22% were yes at the start. Oh, we're going back to that too. So I don't know. Do you think it's kind of a tie here? What do you think?
If no one's mind was changed, then I think it's a tie.
Well, how about a big round of applause for our moderator and our speakers? Thank you.
All right. Thank you so much.
Thanks again.
Thank you.
Well, you know, we have to do this debate again soon on another topic. This was fabulous. What fun. What so much energy in the room, and gosh, so much energy on the YouTube chat too. Thank you all of you watching who were participating. And most of all, thank you one more time to our speakers. And thank you to all of you, and good night.